Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're taking a look at growth and decay models. Specifically, we're going to be talking about money, how we go ahead and how we compound interest. So we're going to consider an initial principal amount. That is the amount we are starting with. P is for principal, all right? We deposit that into an account that earns an annual rate, R. That's still expressed as a decimal, and it's compounded n times per year. So if we were talking about something being compounded monthly, n would be 12. If we were compounding it quarterly, n would be equal to 4. And we go ahead, we say the amount A that is in that account after t years is given by the equation A is equal to P times 1 plus R over N, all to the Nt power. Now, we could also go ahead and compound something continuously, meaning that it's happening instantly over and over and over and over again. It's not just happening, oh, on this date, ooh, on this date. It is continuously compounding. All right, and it says here, again, consider an initial amount, P, that's our principal, deposited into an account at our annual rate, R, and it's compounded continuously. You will see that. If you see that word continuously, that's how you know you're going to be using this function. And it will give you the amount A in the account after t years. We call this the Pert formula because take a look. P e to the RT, Pert. So let's go ahead, let's see how using these different equations and compounding at different values or at different intervals, how it will impact our money. So number 1 says you deposit $9,000 in an account that pays 1.46% annual interest. We want to find the balance after 3 years when the interest is compounded quarterly. So if it's being compounded quarterly, that means 4 times per year. Let's work with our equation. A is equal to the original amount, which is 9,000, times 1 plus R. R in this case is 0.0146 divided by N. N was 4 to the Nt power. So that's 4 times 3 power. Now you could try plugging this into your calculator all at once. Chances are you're probably going to miss a parenthesis someplace. So I work from the inside out when I do this. I'm going to do 0.0146. I will divide that by 4. I'm going to add 1 to that. I'm going to raise that to the 4 times 3 power. And then I'm going to multiply that by the original principal, which was 9,000. And I will see, keep in mind that we are talking about money that after 3 years, we should have $9,402.21 in there. $9,402.21. Now let's say we have that same amount, but now we are going ahead. We are compounding it monthly. So now it is 12 times per year. We'll still start out the exact same way. A is equal to 9,000 times 1 plus 0.0146. This time we're dividing it by 12, and we're raising it to the 12 times 3 power. So let's start from the inside and work our way out. 0.0146. We are dividing that by 12. We are adding 1 to it, and we are raising it to the 12 times 3 power. And then we will multiply that by $9,000, and we get $9,402.71, which you're probably saying, whoop-de-doo, that's not much more, is it? It's not. But did we invest a whole ton of money to begin with? $9,000? That's like nice money. That's not like $9 million, though. And also, let's take a look at our annual interest rate. Back in the day when Mrs. Delzati was a little girl, interest rates were awesome. They were at like 6 or 7%. Now you would be lucky to get 1.46% annual interest. All right. So it all depends on what's going on with how much are you originally going ahead and investing and what your annual interest rate is going to be. Either way, notice that it went from 21 cents to 71 cents. Not significant, but it's still a difference. So with part C then, if I want to find the balance after 3 years when we compound it daily, now n is going to be equal to 365. So we start the same way. That's A is equal to 9,000 times 1 plus 0.0146. We have to divide that by 365. And we're going to raise that to the 365 times 3 power. So again, from the inside on out, that's 0.0146. We'll divide that by 365. We will add 1 to it, and then we will raise that to the 365 times third power, and we'll multiply by 9,000, which will give me $9,402.95. Again, not a huge difference, but a difference either way. Okay, so we now want to find the balance after 3 years if we compound continuously. Continuously, that's our signal. We're using the Pert formula. We're saying A is equal to 9,000 times e to the RT power. That's 0.0146 times 3 power. This one you could probably plug into your calculator all at once. That is 9,000 times e to the 0.0146 times 3 power, and we see that it is $9,402.96. So it's only a penny more, but keep in mind, 9,000 wasn't a huge sum to invest in the first place, and the interest rate wasn't all that stellar. Okay, so that's us being able to deal with compounding interest. If we go ahead, we flip it on over, we're going to review some more with our growth decay and our growth and our decay functions. So if we take a look at number 2, it says the value of a motorhome, Y, in thousands of dollars, can be approximated by the model Y is equal to 31 times 0.92 to the T power, where T is the number of years since the car, not the car, but the motorhome was new. I want to identify the annual percent increase or decrease. Well, I do know that it is a decrease since it is less than 1. If we do 1 minus 0.92, that will give me 0.08, which means I'm talking about an 8% decrease. I want to know when will the value of the motorhome be $9,600. Keep in mind, this is a Y value. So if we put into the calculator into Y1, the original equation, into Y2, we'd be typing in 9.6. Let's go ahead and let's do that. Into Y1, that is 31 times 0.92 to the x, and then into Y2, we're typing in 9.6. Let's go ahead, let's click graph. Can't see a whole bunch right now, but I do know everything is occurring in that first quadrant, so I'm going to change my window. I'm going to go 0 to 20 on the x's, and I'm going to go 0 to 20 on the y's. Keep in mind, if you don't get a good window the first time, you can always go ahead, you can change it. We've got a better looking window there. Let's go ahead, let's do a quick sketch of that graph. Show me that you know that it means decay. And let's find the intersection there. So second trace, number 5. We'll arrow so we're close enough. Click enter once, twice, and a third time, and we get that that is 14.059. So 14.059 and then 9.6. So after 14.059 years, the value will be $9,600. All right, again, your answer should be written in that complete sentence. All right, let's look at number 3. Number 3 says the amount Y in grams of the radioactive isotope barium-140 remaining after T days is given by that equation, where A is the initial amount in grams. I want to know what percent of the barium-140 decays each day. Keep in mind, we want the equation to look like our decay function. Y is equal to A times 1 minus R to the T power. So we've got to go ahead, we've got to work with that. 0.5 to the T over 13 power. First thing I have to do is bust up that exponent. That is Y is equal to A times 0.5 to the 1 over 13 power. And all of that is being raised to the T power. Now we're going to go ahead, we're going to deal with what's inside there. If we do 0.5 to the 1 divided by 13 power, we round this to 4 decimal places, that is 0.9481. So I have Y is equal to A times 0.9481 to the T power. And again, I want it to look like this though. So now I have to do 1 minus 0.9481. And I get that this is Y is equal to A times 1 minus 0.0519, all to the T power. So we can say then that it decays by 5.19% each day. All right, my last one on this side, number 4, says you invest a certain amount in a savings account that earns 2.5% annual interest and is compounded monthly. After 8 years, the account has approximately $30,528 in it. What was the initial amount that was invested? We are looking for the initial amount, which means that we are looking for the principal, the p-value. If we write out our equation, that A is equal to P times 1 plus R over N to the NT power. I'm looking to figure out what P is going to be equal to. So let's see what we know. A, what's left in it right now is $30,528 is equal to P times 1 plus the rate was 0.025. It was compounded monthly, so that's divided by 12 to the 12 times 8 years. All right, this right here is just one giant number. Okay, in order to figure out what P is going to be equal to, I've got to figure out what that giant number is and then do 30,528 divided by it. So let's start. From the inside on out, I have 0.025 divided by 12. I'm going to add 1 to it, and then I am going to raise that to the 12 times 8 power. Okay, this is the number that is highlighted in yellow here. I need to take 30,528 and divide that by it. So 30,528 divided by, let's go get that answer and click enter. What do we see that original principal was? The original principal was $24,999.41. That's what P was going to be equal to. Now, we spent a whole bunch of time dealing with some word problems. There are some problems now that I'd like to work on where it's just straight algebra. All right, so I'd like you to go ahead, find the second video, and we'll chat in just a minute.